Okay, P9.1, motion. Let's start off with the definition for speed or velocity to start with. So if you remember that speed is a scalar, velocity is a vector, and what that means is it only has magnitude, and what this one means, it has magnitude and direction. Okay, so, and the other one which we needed was the difference between distance and displacement. And that is exactly the same again. So this one's a scalar, which means it only has magnitude, and this one is a vector, which means it has magnitude plus direction. Okay, so, and that's important in the next bit, because I don't want you to be confused when we're talking about our velocity time graphs. We know what velocity is. All it is speed in a certain direction. Okay, so what do we measure speed in? What do we measure velocity in? We measure it in meters per second, don't we? So if we say that velocity is in meters per second, okay, well then that tells us how to calculate it. So meters are distance, and this is in time is in seconds. Now, I've already made a mistake there, and the sharper amongst you would have spotted it. I should have used displacement there rather than distance, because velocity obviously depends on direction. So you need to use the vector quantity, which depends on displacement, not distance. Okay, so where it gets interesting is when we start turning that into a graph. So if I want to look at a journey, and I want to say that I've got my distance here, or displacement, and I've got my time here. So let's describe my journey. So it takes me 5 seconds to get started. I'm a bit slow starting. So it takes me 5 seconds to get started, and my distance hasn't increased in the first 5 seconds. So if I make each centimetre worth 5 seconds, I don't get started for 5 seconds. But when I do get started, I walk at a constant speed, so my distance is increasing at a constant rate. Okay, so, and then let's say I do that for 10 seconds. So that's 10, 15. And let's say I do that for 100 meters. I'm really, really fast once I get going. Okay, so it took me 5 seconds to get going, so my distance didn't increase in the first 5 seconds. But when I did get going, I did 100 meters in 10 seconds, a bit like Usain Bolt. Okay, so I could then work out how fast I'm travelling on this section here. So on that section of my journey, I'm going to be travelling at 100 minus 0 over 15 minus 5, which is the same as saying 100 divided by 10. That's 100 meters divided by 10 seconds to give me 10 meters per second. So my speed at that point there is 10 meters per second. But I don't stop there, I do my lap of honour. Okay, and on my lap of honour I'm only jogging now, so I'm not going anywhere near as quickly. let's say that is 120 meters. Okay, and then if you look at the time, 20, 25, 30, 35. Okay, I can work out how fast I was travelling on from here to here. And this one's a little bit more complicated, but not very, because the only difference is I'm just not starting at 0. So on this one I had to do 100 minus 0, but on this one I've started at 100, so on this one I need to do 120 minus 100, and the difference in time is from 35 to 15, so I need to do 35 minus 15, so that means that I'm going to get 20 divided by 20, and that is going to give me equals 1 meter per second. So here I'm going 10 times slower than I am here, so my gradient is 10 times less steep, and that's the gradient, it's just how steep my line is, so how fast is it going up, and that is 10 times less steep than this one, which is going up a lot faster, okay, because I'm travelling a lot faster. Okay, and then if I then head home after doing my lap of honour, and I come straight back home, then my graph goes down, and this tells me that it must have been a displacement time graph. And the difference between displacement time graph and a distance time graph is, on a distance time graph, when I went back home, I'd have still carried on increasing the distance I've travelled, so it's continued to go up. But on a displacement time graph, because it matters how far away I am from home, if I head back home, it goes back to 0, because 0 is home. Because all I care about is how far from home am I. Okay, and then I can work out what this one is here. So that's 40 and then 45. So all I'm going to do is 120 to 0, so that's 120 minus 0, or sorry, 0 minus 120 to be more specific, and 45 minus 35. So I'm going to, so that means I've done minus 120 meters in 10 seconds. So I've done that in minus 12 meters per second. And this minus, it's not too important, but it's a little bit important, because that tells you that what you've been calculating isn't your speed, what you've been calculating is your velocity. Because if the gradient is negative, you get a negative velocity, and that tells you that you're going backwards. That tells you the direction, which turns into a vector, which tells you its velocity.